topology on screen. As we discussed yesterday, both switch will maintain one table to forward traffic. And what is the name of that table? That table is called MAC address table. Yes or no? Both
Yes.
switch will maintain one table called MAC address table to forward traffic. Let's say this is MAC address table of switch 1 and this is MAC address table of switch 2. Getting my point? In MAC address table, switch will learn what? MAC addresses on ports. Whenever switch 1 will receive any frame on 0/1, what MAC address it will learn? On 0/1, what MAC address switch 1 will learn? 0A. 0A is the MAC address of PC1. So it will learn 0A MAC address on which interface? On fast Ethernet 0/1. In the same way, it will learn 0B MAC address on which port? Yes, Wally. It will learn 0 MAC address on which port? F0/2. Because on this port F0/2, PC is connected whose MAC address is 0B. In the same way, switch will
Is it not
learn.
recording, sir?
Yes, recording is started. In the same way, switch 1 will learn 0C MAC address on which port? On
It's 0/3.
F0/3. And switch 2 will learn 0D MAC address on which port?
0/1.
On 0/1. Very good. And 0E MAC address on which port?
0/2.
0/2. And 0F MAC address on which port?
0/3.
0/3. Right. Now I am going to connect one link between switch 1 and switch 2. Let's say this is 0/5 and this is also 0/5. Switch 1 will learn how many MAC address on 0/5? See, 0/5 is connected with one another switch. Yes or no? 0, this port is connected with switch 2. And switch 2 have these MAC addresses in their MAC address table. Switch 2 have connected with these user. So switch 1 will learn all these MAC address on which port? On 0/5. Yes or no? And switch 2 will learn these all MAC address on which port? On 0/5. Yes or no? Is it clear?
Yes.
Right. So switch 1 will learn 0D as well as 0E as well as 0F MAC address on which port? On F0/5. So see guys, this is one interview question. Can switch learn more than one MAC address on a single port? So answer is yes. Switch can learn more than one MAC address on a single port. In the same way, switch 2 will learn multiple MAC address on F0/5 port like 0A, 0B and 0C. These all MAC address it will learn on F0/5. Getting my point? This is the MAC address table of both switch. Now, let's say IP address of this machine is 10.1.1.1 and IP address of this machine is 10.1.1.10. So if 10.1.1 want to communicate with 10.1.1.10, source MAC address will be what? 0A and destination MAC will be what? 0D. Am I right?
Yes.
Source IP will be 10.1.1.1, destination IP will be 10.1.1.10. After that, it will forward this frame to switch. When switch will receive this frame, it will receive on which port?
01.
On 01. First of all, it will do what? The first function of switch. It will update the entry on this particular interface. It will update the entry on particular interface, this entry, because by default this entry is for 300 seconds. So let's say some time has gone and here timer is 150 second left. So again, if it will receiving any frame on this port, it will set 300 second. Timer will reset over here. That means it is updating the entry on the particular interface. It will update the entry on this port. And after that, as you know, source is 0A, destination is 0D. It will check what? Source MAC address first. It will update the entry, then it is going to check destination. So destination is 0D. It will look up their MAC address table to find the exit interface for 0D MAC address. So for 0D MAC address, exit interface is F0/5. So it will forward traffic from this interface. This is how switch forward traffic. Yes or no?
Yes.
When switch 2 will receive the frame, in frame source is 0A and destination is 0D. When switch 2 will receive this frame, it will also update their table, right? This table, this entry for 0A MAC address. After that, it is going to check destination MAC. So destination MAC is 0D. Always keep in mind, first switch check source MAC address. On the basis of source MAC address, it will update the entry in their MAC address table. If entry is not available, then it will add one entry in the MAC address table. After that, it is going to check destination. So here destination is 0D. So it will look up their MAC address table again. In MAC address table for 0D MAC address, exit interface is fast Ethernet 0/1. So it will out the frame from this particular interface. And this is how this PC will get frame. Am I right? Is it clear to everyone? Or if anyone have doubt in this packet flow, guys, let me know. If anyone have doubt in the packet flow, let me know. No?
No.
Okay. Now, when this switch will generate one broadcast message, let's say here MAC address is 0A source and destination MAC is, let's say, all F. All F means broadcast. When this PC will generate any broadcast message, let's say it is an ARP message or any other broadcast message, so it will forward to switch. Now this time again switch will update the entry first. It will check source and it will update this entry. After that it will check destination. So this time destination is what? Broadcast. So it will send one copy from this interface, one copy from this interface, and one copy from this interface. Am I right? When switch 2 will receive the broadcast frame, again it is going to update source MAC. It will update this entry and after that it will check destination. Oh, destination is broadcast. It will forward one copy to this computer, one copy to this computer, and one copy to this computer. Is it clear to everyone? Any doubt in this? How switch is going to treat broadcast packet? Any doubt? Any confusion in this?
No.
No. Okay. Now what is problem? Problem is between switch 1 and switch 2 I have only one link. If this link will guys goes down, then can these user communicate with this user? No, because there is no connectivity between switch 1 and switch 2. So in real time we will have multiple link between switches. In real time, like in routing also we have discussed, let's say R1, R2, R3 and R4. If R4 have some network, so I have two paths to reach R4. Why? One is the, let's say, primary path and one is the backup path. So backup path is compulsory in networking. But between switch 1 and switch 2, we don't have any backup link. Yes or no? Yes or no, guys?
Yes.
So I need to connect one backup link over here. Let's say this is my backup link between router 1 and switch 1 and switch 2. This is, let's say, F0/6 0/6, and here also 0/6. Now I have two link between switch 1 and switch 2. Now I have backup link. If one link will goes down, I don't have any problem because I have one backup link. Yes or no? If this link will goes down, still this user can communicate with this user. Yes or no?
Yes.
But see what problem we have here. If now this PC will generate one broadcast message, source MAC is 0A and destination MAC is all F. It is generating one broadcast message. Switch 1 have generate one broadcast message. It will forward to switch. Switch will forward one copy to this interface, one copy to this interface, one copy to this interface, and one copy from this interface. Yes or no?
Yes.
When switch will receive a broadcast packet on this interface, it will forward from this interface. Yes or no? One copy from this interface, one copy from this interface, one copy from this interface. Yes or no? When it will
Yes.
receive broadcast on 0/6 interface, it will also forward from this interface. Again, switch 1 will receive same broadcast message and it will forward to this interface, broadcast to this interface. Yes or no? So my
Yes.
frame will be moving between switch 1 and switch 2 for lifetime. Yes or no? Yes or no?
Yes.
Because see now, when switch 2 will receive broadcast message on this port, on F0/5 port, so definitely it will forward that broadcast from this port. When it will receive broadcast message on this port, it will forward from this port. So this is loop. Again, switch 1 will receive broadcast message on this port and it will forward from this port. So this is what? This is loop. This is loop. So whenever we will connect more than one link between switches, guys, automatically loop will form. Getting my point? So to avoid this loop, by default, a protocol is running on switch. That protocol is called STP. STP. On both switches, by default, a protocol is running. That protocol is called STP. And what is the use of this protocol? This protocol is responsible to avoid layer 2 loop. STP stands for okay, guys. STP stands for Spanning Tree Protocol, and this protocol is used. It is used to avoid layer 2 loop. Is it clear? And by default it is enabled. By default enabled. Is it clear? Now question is how a spanning tree protocol or STP is going to avoid the loop. Guys, it is very intelligent protocol. What it will do, between switch 1 and switch 2, it will block one link. Maybe it have block 0/6 interface. It will block this port until and unless upper link is up. If this link will goes down, automatically a spanning tree protocol will activate this port. Getting my point? Whenever we have more than one link between switches, then a spanning tree protocol will block one link backup path, and when primary link will goes down, automatically it will activate the backup link. Getting my point? What I am saying? A spanning tree protocols will block the backup path until and unless primary path or main path is available. If primary path is not available, then backup port will be activated by a spanning tree protocol automatically. It is a layer 2 protocol which is used to avoid layer 2 loop, and by default this protocol is enabled. And see how it's work. In packet tracer, I am going to take two switch. Let's say switch 1 and switch 2. S1, S2. Is it visible? Is it visible, guys?
Yes.
I am going to connect two link between switch 1 and switch 2. 0/1 and 0/2. I have connect two link between switch 1 and switch 2. And let's say I have some PC here. PC1, PC2, PC3, PC4.
Why did you connect with two lane?
For the backup purpose. If I have only one link, that means I don't have backup between switches. So that's
Okay.
why I have connect two link.
With the real device, can we do like this?
Yes, in real time only you will do like this. And you can see, are you able to see one port is blocked between switch 1 and switch 2? See this port 0/2 is blocked.
Yeah.
Why? Because of a spanning tree protocol. Because of a spanning tree protocol. So on a switch, you can verify that by default this protocol is enabled. How you can verify it? By running command show a spanning tree. This is console of switch 1. On switch 1, I am going to write one command show a spanning tree. So here you can see by default a spanning tree is running. By default a spanning tree is running for VLAN 1. We will discuss VLAN also. Don't worry. Okay, and all ports of this switch is in forwarding state. Are you able to see forwarding here?
So instead of we can put command like show protocol.
No, here
will
we
show the-
cannot run show protocol. That command is for router.
Uh-huh.
On
Here we need to speak.
yes,
right?
on switch you have to check particular protocols manually.
Okay.
So here I have checked so a spanning tree protocol is enabled on switch, and all ports of switch 1 is in forwarding state. This is the port between switch 1 and switch 2, 0/1 and 0/2, and these two are the port which is connected with PC. In the same way, on switch number 2, if you will run show a spanning tree command, here I am going to run show a spanning tree protocol. So here we are able to see one port is blocked and rest ports are in forwarding state. Getting my point? One port is blocked, that is 0/2. See, 0/2 is blocked. So what will happen if I will disable the spanning tree protocol on this switch? Let me disable a spanning tree protocol. To disable, just you need to run one command. See, by default a spanning tree for VLAN 1, this command is enabled. I am going to remove this command to say no. No a spanning tree VLAN 1. And now if I will run command show a spanning tree, here you can see no a spanning tree instances exist. In the same way, if I will disable a spanning tree on switch number 2 also, then both port will come in forwarding state. No spanning tree for VLAN 1. See, now all ports are in forwarding state, yes or no? Now here is problem. Loop can form between switch 1 and switch 2. You know how loop can form? If any machine will generate a broadcast message, let's say here I am going to configure one IP 10.1.1.1. So see, all ports lights is blinking, yes or no? That means we have loop.
Sir, I have a quick question.
Yes.
What is the purpose of the interface? The interface was blocked. Like if is
See, if port is not blocked, then seen a loop have formed here. All ports are blinking. That means there is no problem in network. Why it's happen? Because of one reason. Because of only single reason is there, guys. Why loop have formed here? See what happened exactly. I am going to make you understand. I have configured the IP address over here. Whenever you will configure IP address, it will generate one Gracious app to check duplicate IP address. To check duplicate IP address, here I have defined IP 10.1.1.1. It will generate one Gracious ARP. Gracious ARP will be broadcast. Source MAC will be the any MAC address of PC1, let's say 0A, and destination MAC is all F. Broadcast. It will forward this broadcast frame to switch. Switch will forward it to one copy from this interface, one copy from this interface, one copy from this interface. When switch have received broadcast message on this interface, it will forward that broadcast message from this interface, from this interface, from this interface. When it will receive broadcast message on this port, it will forward from this interface. And for lifetime here, frame will be moving. Getting my point? Between switch 1 and switch 2. So that's why a protocol is running by default, that is a spanning tree protocol. Getting my point? So that loop cannot form in the topology. Is it clear?
Yes, it's clear.
Right. So here I have to enable a spanning tree protocol to avoid this problem. Right now you can see, if you will check MAC address table. So MAC address table. So in MAC address table you can see there is 3 entry. There is 3 entry. On 0/1 it have learned this MAC address. On 0/1 it have learned this MAC address. Okay. On 0/B it have learned this MAC address. And on 0/C 0/2 it have learned. See, on same port it is learning 2 MAC address. That is fine. But after some time this MAC address is swapping. This MAC address is swapping. See now, here we have loop in the topology. That's why all ports are blinking. So here I have to block one interface. So you have one option. You can manually run shutdown command on backup path. Let's say on switch 0/2 I am going to run manually no shutdown command. Interface F 0/2 says shutdown. See, now problem is solved. Yes or no? But it is not possible to assign one engineer there, right? To shut down the port and to run no shutdown command whenever primary link will goes down. So that is not possible. So that's why we have a spanning tree protocol. Here I am going to run no shut command. Again you can see ports LED start blinking. That means there is loop. So that's why we will run a spanning tree protocol for VLAN 1. A spanning tree protocol, and a spanning tree protocol will automatically put one interface in forwarding state and one interface in blocking state. Whenever primary link will goes down, it will activate the backup link. It will activate this port. Getting my point? So see, a spanning tree have blocked this interface F 0/2 on switch number 2. Now question is, why switch 2 have blocked the port? Why not switch 1 have blocked the port? That can be your question. So that is different thing. We will understand that. Is it clear till now?
Yes, but how do you know it's on VLAN 1?
Because by default VLAN 1 exists on switches. Only one VLAN exists on switches, that is VLAN 1. This is by default in operating system.
Okay, thank you.
One VLAN is in operating system, that is VLAN 1, and this VLAN is called management VLAN. Why we called it management VLAN? Because we are using VLAN 1 for management VLAN, and by default all ports of switches are member of VLAN 1 only. If here I will run command show VLAN, so you can see these all ports are member of which VLAN? VLAN 1.
VLAN.
Okay, so don't worry, we will understand VLAN configuration. For now, just try to understand what a spanning tree protocol, STP. So what is STP, guys? What is STP, a spanning tree protocol? You can say it is a layer 2 protocol which is used to avoid layer 2 loop. Just practice like this. It is a layer 2 protocol which is used to avoid loop. And how a spanning tree works: whenever we have more than one link between switches, then a spanning tree protocol will block one link, and whenever primary link will goes down, it will again activate the backup link. By default, a spanning tree protocol is enabled on switches. So we have, if we have more than one link, it will block the backup link, and if primary link will goes down, then it will activate the backup link. Is it clear? Is it clear, man?
Yes, it's clear.
Yes.
To everyone?
Yes.
Great. You know, before a spanning tree protocol, I should discuss VLAN concept, but no problem. If I have started a spanning tree protocol first, then first we will understand this, and after that we will understand VLAN concept. So now question is, why this port have block only, right? Why not switch one have one port have block, or 0/1 port have not block, only 0/2 port have block? Guys, for this understanding, right, for the teaching purpose, there is some terminology. You have to understand some terminology over here, then only I can make you understand why 0/2 ports of switch is blocked. So again, I am going to design one topology here. Let's say switch 1 and switch 2. As you know, all switches have one base MAC address. All switches will have one base MAC address. That MAC address is again in the operating system. Let's say this is switch 1, and this is switch 2, and base MAC address of this switch is 0A, and base MAC address of this switch is 0B. If you want to check back base MAC address of switch, just you need to run one command, like this is console of switch 2. I want to check what is the base MAC address of this switch. So I will run command show version. In show version, I can see base MAC address. Are you able to say base MAC address? We already discussed about MAC addresses, that it is an 48-bit address, how to represent it in the basic module. Yes or no? So this is base MAC address of switch 2. In the same way, switch 1 will also have one base MAC address. If you want to see the base MAC address of switch 1, I can show you. So version. Here we can see base MAC address of this switch. It's this one. 1 minute. So see, if I have two switch, one have MAC address 0A, two switch have MAC address 0B, and I have one more link over here. Okay, let's say I have only one link. In a spanning tree protocol, First of all, what a spanning tree protocol will do, it will elect one switch as root bridge. Protocol will elect one switch as root bridge. Root bridge, like you know, DR router in OSPF. Remember the DR router, designated router, are the main router. In the same way, spanning tree protocols are going to elect one switch as root bridge, one switch as a main switch. Now question is, which switch will become root bridge? Yes or no?
Yes.
So the switch which will have lower bridge ID will be elected as root bridge. Getting my point? Now again question is, what is root bridge ID? Yes or no? It is clear that switch which will have lower bridge ID, that switch will become root bridge. Now question is, what is root bridge? Bridge ID. The switch which will have lower bridge ID, that switch will be elected as root bridge as a main switch. Then question is, what is bridge ID? So guys, bridge ID is combination of two things. Bridge ID is combination of two things. Bridge ID equals base MAC address, plus priority. And by default, priority on every switches is 32768. This is by default priority on all switches. Like if you want to check by default priority on any switch, just you need to run command show a spanning tree. And you should also run this command show a spanning tree just for practice. If you are not getting the output, no problem, but just check the small things. This is base MAC address, MAC address, and this is priority. So if priority of this switch is 32769, so actually this is 768 plus VLAN ID. That's why here we are able to see 9. Because here a spanning tree protocol is not running, by default PVST, per VLAN spanning tree is running. That is Cisco proprietary protocol, and we are checking configuration on Cisco devices. That's why we are able to see priority 32769. But by default priority is 32768 and plus MAC address. So if I have two switch, what will be the bridge ID of switch 1? Base MAC address 0A and plus priority, that is 32768. What will be the bridge ID of switch 2? 0B and priority 32768. Priority is same on both switch, you can see. Yes or no? But base MAC address is different. Two devices cannot have same MAC address. MAC address is globally unique, guys. So two devices cannot have the same MAC addresses. So now according to you, you tell me which switch will become root bridge in this scenario. Which switch will become root bridge?
Should be switch 2.
Switch 2. Why, brother, switch 2? Switch 2 have higher bridge ID. Here you can see MAC address is 0B. On switch number 1 you can see MAC address is 0A. So which ID is lower? Switch 1 ID is lower or switch 2 lower ID is lower? Switch 1 ID is lower. Switch 1 bridge ID is lower. Yes or no? So let's say I have multiple link between switch 1 and switch 2, and switch 1 have become root bridge. Now this switch is my
How
root
do you
bridge
know
in
which one is
short.
lower and which one is like higher? This both are
Oh,
same.
if you will compare 0A and 0B, so you tell me which one is lower, which one is higher.
01 is 0A is lower.
0A is lower, 0B is higher. So in
Yes.
the same way here also I have 0A, here I have 0B.
Okay, got it.
Now all ports of root bridge will be in forwarding state. All ports of root bridge will be in forwarding state. This port will be become designated port, DP. DP stands for designated port. DP, this port will also become DP. This port will also become DP. DP. And switch number 2, that is not the root bridge switch. So these all ports are not going to become DP. Okay, so in next class I will make you understand how switch 2 will block one port here. But today just we had discussed root bridge election in a spanning tree protocol. We had understand what is a spanning tree protocol. So a spanning tree protocol is a layer 2 protocol which is used to avoid layer 2 loop, and by default this protocol is enabled. We don't need to configure it, just we need to understand it only for the troubleshooting purpose and for the interview purpose. After that we had discussed the one switch in the switching network will be elected as root bridge switch. So which switch will become root bridge switch? So switch which will have lower bridge ID, that switch will become root bridge. After that we had discussed what is root bridge ID. So root bridge ID is a combination of two things: base MAC address plus priority. By default priority on switches is 32768 and MAC address is globally unique. So on the switch, if you will check bridge ID of this switch, so what will be the bridge ID of this switch, guys? 32768 plus this MAC address. This is what bridge ID. Okay, and this is switch 2. So switch 2 have, you can see, one port in blocking state and all other ports are in forwarding state. Don't worry, tomorrow I will make you understand this. How many port role are there in a spanning tree protocol? Actually there are three types of port in a spanning tree protocol. One is RP DP, designated port. Other one is RP root port, and other one is, last one is blocking. And from the blocking port user cannot forward data, but from RP and DP port user can forward data. Getting my point?
Yes.
If you are feeling difficulty to understand, don't worry guys, just I have start the switching module. That's why you are getting some difficulties to understand, but day by day these things will become easy for you. Okay.